We'll just wait one more minute and then we'll get started. Okay, hi everybody. Good evening. So if you recall, in our last class, we tried to cover the remaining things of chapter 1 and also give you, some details on the research type, grants, hypothesis. So the plan for today is we'll move to chapter 2, which really talks about how to identify a research problem and how to solve the research problem. So that's chapter 2. So before I go into chapter 2, a couple of things. One is that the discussion, you have been doing well. The quiz, I found that some people missed the quiz, so I kind of opened up again. So those who have missed, since this is first time, I'm extending. So please take the quiz and don't worry about like how many mistakes you have done. The goal of these quizzes is that at least you are going through the slides. At least you have some idea, okay, what we are talking about. That should be okay because anyway, you'll be doing your own research, own survey, and those who are taking for the first time, by the end of the semester, I really want a survey paper. And those who are taking this class for the second time, for you is the grant proposal. But actually, grant proposal I mentioned in our last class. Grant proposal is similar to your dissertation proposal, but I don't say dissertation proposal. And also, if somebody writes a paper in his or her area of research, that will be good too. Okay, so that's kind of the plan. So let's move into today's lecture. So this is from the book, chapter 2. So if you just go through the slides, it should be enough. But in case any of you wants to go through the book, you can do. Some of you have a newer version. I say kind of same. Okay, so today's topic is the research problem. Okay, so identifying a research problem and how to approach, that's the part. Okay, so we're going to talk about that. So before we go into that, when you find a research project, usually research projects are of two types. One is basic research and the other one is applied research. When you say basic research, basically it means that in a particular foundational subject, you're trying to contribute something really new. That's the basic research, which is physics, chemistry, biology, right? Some basic research, or even in a particular subject, you're trying to enhance the knowledge. Okay, but applied research is, you are trying to really see the applications, applications of something, some approach or newer method, a newer way. That's applied research. In applied research, most of the time we see something is working. For example, my group, we do digital health, mobile health is applied research. What we do is that we try to use the foundations, some of the theory of computer science and try to address, healthcare problems. Okay, to do that, we use machine learning. Sometimes we use some other things, text messaging, video messaging. all falls into, applied research. So basically, for basic research, I mentioned, it enhances the basic knowledge of a particular area. For example, physical world, biological world, psychological world, even if it's social science, it's a social world. So it kind of sheds light, uh, if it is, social science, or if it is history in some of the phenomena, some of the cultural thing, really uh, uh, trying to shed new light, so that you get you are really enhancing the foundations. In applied research, it's like, really addresses like something which is relevant to the current practices, procedures, policies. Um, for example, some of the human decision making for practical problems. When you say practical problems, it may be some, let's assume, for some cancer, specific some cancer, you are trying to find out something. So these are applied research. And uh, in applied research, if you recall in our last class, when we were talking about different types of research, one of the research was like action research, where you are trying to solve some immediate problem. Whatever work environment, here is some things, there are some unanswered questions. You are trying to address that. That's action research. So if you recall, we talked about quantitative research, where we look for some quantity numbers, qualitative research, mixed method, action research. So actually, here in applied research, some of the things are action research, because you are really trying to do in a working environment some of the unanswered questions you are trying to answer. So in research, all of us know, identifying a suitable research problem is hard, honestly, because if you can really identify a really good problem, if you can identify a good problem, then for that particular problem, if it is a kind of existing problem, so what you do, you compare with the benchmark. Okay, that means incremental research, which I mentioned in last class. That's the incremental research. Or you really come up with a really new things, and whatever solution you give, uh, that's something new, because nobody has done, right? You are the first person try to give some solution. So, but even when you give the solution, you have to show that it's working. That's why we do the evaluation. So identifying a suitable research problem is what we do is that in each of your area, try to see if you can address some important questions, and that important question is not answered. For example, you are trying to find out why it happens. For a specific uh, maybe type of cancer. Okay, and uh, for that particular type of uh, cancer, you are trying to see what's the cause. If the causes are not known, that's a research question, right? That's a research question. That's also important question. You are trying to find out the cause. And when you do research, always try to think, whatever you are trying to find out, is it making a difference? Like, whatever the state of art, is it changing? Is it making a change? Is it making a difference? So uh, uh, you should pick some research problem which really advances the current knowledge. That means, you are adding to the current knowledge. And to add the current knowledge, what you may have to do is that you have to think new ways to solve that. You may suggest some possible applications, and if you keep doing that, may uh, pave the path, for even further research. So you try to come up with something, and that may stay for some time. So usually for my PhD students, I usually say, okay, pick something, you come up with some solution, then that area should stay few years, like 4 or 5 years, in your, at least 4 or 5 years. Because in that particular area, you may have solved something, and then something is not. Then you can still stay in that area, and keep on adding, more knowledge. Okay, so you are advancing the knowledge. So that's the way it works. So for finding suitable research problem, it's hard. That's why, either you talk to an advisor, you listen to the presentation, you look at the literature, and from there probably you can find out a good research problem. Okay, so for example, in our class, Jane, she's looking for firefighters. They have respiratory problems. Okay, and what is the cause? How? Some of the, so she already find out that one because she works in that area. So I'm just giving that example. So even in your own area, you can find out something, but you have to make sure that you know the literature, what has been done, and you are advancing that knowledge. So finding a research problem, suitable problem, will enhance the research. Okay, so even in our class, I know some students research. For example, Masood, he is trying to work on brain signal analysis, so that he wants to know how people learn, and for their education and other things, how brain signal helps. So that's one of his one. So similarly, I'm sure other people have, everybody is doing something. So if you can identify, for example, here in my class, I have one student, Nafi. He is working on white cell count. One of the problem is that, okay, if you want to do white cell count, you have to poke and find out. So he's trying to do something non-invasive way. Can we do that? Okay, so you see, those are some of the example. I'm sure others are here, they are working, and some of you are taking this class second time. For example, Nidhi, what is your area of work, Nidhi?
I'm just doing research in like Twitter analysis.
Yeah, go ahead.
Yeah, I'm just a PhD cat, like research assistant, so I don't do any outside work. But since I also taught like computer science, like programming languages, I was really interested in the education side as well, which is why I did the data science project, and I'm working on that right now as well.
Okay, so in your area, find out something suitable, and then you can go from. So we will talk about more, and for some of you, you're taking this class second time, right? So it will be a little bit of repetition, which is okay. I'm sure some of you have forgot some stuff, but it will be good to talk, right? For example, in our last class, we talked about how you do, like, remember all those steps, cyclic steps. So if you can do that always, that always help. So what I'm referring to is that if in your last class, if you recall, at the end we have a cyclic one, right? The steps, how you do, right? Okay, so these always help, right? Because this is a class, a research method. We'll repeat some stuff, but I think it's okay. Identifying suitable research problem. Then when you find out a research problem, what to consider, and actually there is no certain rules, but some guidelines, some guidelines. One of the guidelines is that, okay, you do something, sometimes we do research, you really like it, right? But it's not always like it. you have to do something more meaningful. It's more than self enlightenment. So that means you are really not only fulfilling your own, but also doing a little bit more. Okay. And even when you consider a research problem, think about if you have a data set, if you have two data set, you should think about more than the data set. You might want to compare data set, but you might want to find out even little bit more, that okay, from those two data set, is there any common patterns? Okay, what are the things we can refer? Okay, is there any causal inference from one to another? So that is a little bit more than data set. So in your research, you might have data set, but you need to do more, contribute something new. If you can identify even some among whatever in your domain, if there is any relationship among the data set, and even if you have some relationship, you find out, can you give a name? Can you interpret that, okay, it has something meaningful? Like the way, when you have a lot of data, right? After you do lot of transformation, all those data might get clustered, right? The features might get clustered, and when you have a cluster, you can give a name for that. It is meaning that, okay, this cluster represents something, let's assume sensitivity, right? So that's the part which is, if you can identify the relationship, some of the things, it may have some meaningful thing. That's really new. And there is no, if you think about yes, no, answer, no. We need to go beyond that, right? Even if it is yes, why it is yes, why it is no. Okay, what are the things we need to do, change, so that change. So for finding a legitimate research problem, is there any straightforward way? No, but some guideline is that, some of you have already find out, right? Which is, you talk to an advisor, you join some group, right away get something, right? Or some area you really like. So what they're saying is that, okay, look around you, read the literature, seek advice of experts. Okay, you can talk to an advisor, you can talk to other professors, and then, because, even in your committee, you might want to invite some other committee members, right? So some of their knowledge your advisor works in some area, but some other people's knowledge may be helpful. So it's okay to talk, to know. But actually, this is the class where I try to kind of compile whatever I know, from different professors' research. But even then, it will be good that, for example, if you work as a TA, you can talk to your professor and seek advice. Seek advice in a sense that, even if you discuss, that will really help. Then attend professional conferences. Okay, that's also help. In our department, we have something, we have colloquium talks. So I really encourage you to attend the colloquium talks. Even if it is not your area, it's okay to go there and see, because when you go there, you'll see how people present. Okay, you see how people ask questions. Okay, how the person is answering. Right, those are really, really important. So then it may trigger something. Even in your research problem. Okay, so attending professional conferences, talks I mentioned. Choose a topic that intrigue and motivates. Okay, for your research, yeah, you should choose something which really you have interest, right? Motivates. For example, yeah, Jane, you are kind of the focal point, because I really liked your one. You said you work in an area, right, with the then from there. So you see, like some topic, really intrigues you or motivate you. That's the best way. Then then you can even make progress with joy, and because you are doing research, trying to solve something. If you are not really interested, you are not motivated, it's hard, right? Yeah. And when you do that, sometimes also it's not in your own fulfillment, but see whether it attracts other people's attention or not, right? That will be cool, right? For example, I was talking about, wow, we are doing white cell count without uh, poking your finger, right? So you'll think like, okay, everybody does that, right? So that's kind of draws at other people's attention, right? I'm just giving you an example. So uh, 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 among the guidelines I mentioned, how many of the things you can brought, and obviously you need to be really realistic. Don't try to solve like many problems or big problems which is not possible to solve in 3 to 5 years, right? Okay, so try to do something which you can accomplish. That's a really good thinking. Uh, and that's why later I'll talk, whenever you have a research problem, you want to split the research problem into smaller sub problems, and then you attack sub problems, right? So that's the way. So here today I'm really teaching how you come up with a problem, research problem, okay, and what to consider, and we move forward that way, okay. So when you identify a research problem, it will be really good if you can write the problem statement, okay. Write the problem statement. When I say problem statement, means what are you trying to solve, right? And what are you trying to solve? You write it clearly, really write it down. Then you see it will be more clear. And see, when you write it down, you can go a few more times and see what does it do. Okay, does it really reflect what you are trying to do? And particularly when you write it down, try to write very precisely and really with absolute honesty and integrity, they're saying, because when you write down, do you really mean that? Do you really try to solve that, right? Okay, bring those things. And when you do that, reflect open-minded. Open-minded means something you are thinking, you will solve, but also consider the surroundings. Does it have an impact, right? So that may really help. And the example I mentioned, I think in one of the class, for the malaria parasite detection, remember, if you do the blood test, it takes like whole day or even couple of days. So in Africa, there was a problem. So uh, uh, so what happened? One of the material science professor, he attended that a talk, and he found that, okay, people are talking. He's not from that area, and he brought his. He thought, okay, can I apply some of those material science property here? And he really found something which is bring the magnetism, and it behaves differently, right? So in research, you have to have open-minded. You never know. You may even come up with a really some simple solution of a problem, of a complicated problem. Okay, and whenever you write that statement, the research problem, edit it few times. Go over few times. So if I ask you to, like, okay, even in your area, let's spend a couple of minutes, each of you, what problem are you going to solve? Maybe just in a sentence, if you can write it down, right? If each of you try to write it down, and you'll see that it will be really clear. If you cannot write it down, then go over a couple of times. So next 2 minutes, I'll ask you to spend time to write a problem statement, okay, which is also purpose statement, you can say, because for a research problem, you are trying to write a statement, okay. Um, so next 2 minutes spend on that, then I'll come back and I'll ask you, and we'll go from there. Okay, 30 seconds. Okay, so who wants to go first? Any volunteer?
I can go.
Okay, please go ahead.
So my research, pretty much the question I pretty much have to answer is how to build teaching resources for teaching blockchain for teaching blockchain to undergraduate computer science students and software engineering students.
Okay, so that's the question, right? You're trying to answer. So in the problem statement, you need to like kind of describe so that it looks like, in a couple of sentences, it reflects. It can be even smaller. And so the way you are saying, how to write, okay. So if you write it down, go over a couple of times, and then you'll see that you will come up with a problem statement. Really, you are trying to teach what blockchain for the undergraduate students, right? So can you say it again so that everybody gets it?
Yeah, so the question would pretty much be how to create and what teaching resources have to be created to facilitate teaching blockchain in undergraduate courses.
Okay, excellent. So you see, his one is like what, 2 sentences or something, right? So that's the way we kind of formulate, and this problem statement is very important. That okay, that whole thing you can describe in 1 sentence, 2 sentence, then you can expand it like for a elevator talk, 3 to 5 minutes, and you expand it for a lunch talk like 20 minutes or so. And then it's a real talk, which is 40 minutes or so, 40 to 50 minutes, right? So you need to be prepared. Okay, who wants to go next?
I can go.
Okay, please go ahead.
My research and purpose of my research is finding a robust neural network, which is robust in attacks, because near all of the neural networks are prone to attack. And if you have a perturbed image applied to the network, your network will be fooled. So how we could have a network, especially I'm working on graph neural network, to be more robust in front of the attacks.
Okay, so you mentioned 3 things, right? So in a problem statement, you need to write it down, right? You are trying to build a robust, attack resistant neural network, right? Something, so that's the way we write the statement, right? Okay, good. Okay, who wants to go next? Maybe we do one more.
Yeah, I can go.
Rahan, please go ahead.
Yeah, I have reading some papers and I found a problem like how to measure the concentration of glucose level in your blood using like skin tone or something, in for diabetes patient, it's changing the skin, so it can be a good research field.
So your problem statement will be like how to determine the blood glucose level, right?
Yeah,
Okay.
yeah.
Level. So you are probably saying in a non-invasive manner, right?
Like from some videos or something like a fingertip video, like There's some technology like using the laser, we can measure it, some methods. So it's it's need a wearable device or something like that.
Okay, so because as time goes, we'll refine things, but at least it's a good starting point.
Yeah.
How you are writing a problem statement. It's a purpose statement. Okay, so the rule is that what you do is that your problem, that particular problem, you try to split into sub problems. Okay, a lot of time you are trying to address like too big problem, right? And too big if it is too big, with one or with one question you cannot solve, right? Okay, you are answering one question, it will solve, right? So basically a problem consists of a number of sub problems, and when you say sub problems, each sub problems need to be very specific, and each sub problem should be kind of measurable, and each sub problem really address something specific, right? So it comes from problem into sub problem. Okay, problem into sub problem. So problem into sub problem. But another term we'd like to introduce is that, okay, we understand that we are trying to problem, we are splitting into sub problem. Okay, sub problem is also very precise, and concisely what you are trying to solve. But another term is called pseudo sub problem. Pseudo sub problem is that when you are working in some area, some of the things will come kind of naturally, but those does not have very clear, concise, description, right? Those are kind of pseudo sub problem. The word pseudo says, and if it is pseudo sub problem, what happened before you even go to your sub problem, pseudo sub problem really need to be solved or addressed, like and some of the pseudo sub problem are addressed by with common knowledge. That okay, with common knowledge it will be like this, or with some changes, with some creativity. Okay, so straight away you may not get sub problems, you may get pseudo sub problems, and from pseudo sub problems you may go into sub problems when you really try to address a specific thing with further knowledge. So sub problem as pseudo sub problems, those goes in your problem domain, and we understand that if it is pseudo sub problem, we should really move into sub problem, because if it is sub problem, then you are really addressing something, right? And for that you have a solution. It's a precise. So how how to address a sub problem? So before you address, what you do, you need to know the characteristics of the sub problems. Okay, so characteristics of the sub problems is that it should be a researchable issue, something very specific in its own, it has its own merit. And your sub problem, try to see if you can relate with some data, because with some data you will try to interpret that, right? So each sub problem, see what are the data is related to do. Okay, and then when you are doing sub problem, you always think about if you solve all those sub problem, can you solve the big problem? So that is a big problem split into sub problem. You solve the sub problems, then you get the solution of the whole thing. It's kind of totality of that one. And the when you have sub problems, one of the rule of thumb is that don't have too many sub problems. Then it's hard, right? Try to have reasonable sub problems. So in research, what we usually do is that we say, okay, you try to you have a goal, which is kind of the problems you are trying to solve, and then you have 3 or 4 aims, or you can say 3 or 4 sub-aims, 3 or 4 aims or sub-problems, right? Or even sometimes instead of aims, we say objectives, aims, objectives, kind of similar meaning. So actually, whatever you are solving, that's the goal, right? That's the goal. And your goal, the problem, is consist of sub-problems and aims, objective. Okay, so that's the way. So I usually tell my students is that have just one slide, right? Where you have a title, that's your goal, and you write the aims. So if you really got it, you write the aims, right? Okay, and when you have the aims, for each of the aim, you can see what are the research questions you are trying to solve. It may be one question, research question, maybe two research questions. You see, that's the way it works. Okay. So problem, sub-problem, and how we know this is a good sub-problem. Here, you know, I have something I mentioned about, okay, you relate with some data, all the sub-problems together solve something, you know, as a totality. And you cannot have many sub-problems. I already give a guideline. Try to have 3 to 4, you know, 3 to 4. Sometimes even some people do 2, and each of them has even sub-sub. That's also okay. Okay, but if it is just one, then what happened? Your problem and sub-problem is same, right? Okay, we cannot have it. So you should have like at least 2. You can have 3 or 4, or if it is 2, you can split into that way. Okay, so how do you identify the sub-problems? So identifying the sub-problems is, there is no straightforward way. What we do is that we start with pen pencil approach. You know, write down the problem, and for that particular problem, see you know what is there inside that problem, subtopics, topics. You know, and even you know, when you write it down, maybe you find out, you know, several keywords, right? And those keywords, and then see if you can relate with some data. Sometimes what you do is that you try to draw some diagrams or graphs, what you are trying to achieve. So for example, you are trying to find out something where you really want a good accuracy, right? 95% accuracy. So for example, Ryan's blood sugar level, right? Okay, we really want more than 90% or something. Otherwise, you know, it's not worth it, right? So with pen pencil, you know, you can have you know, that kind of you know, idea you can find out, right? Okay, like, you know, you get something. For example, the accuracy I mentioned, right? So that's kind of you know, addressing a sub problem, right? Okay, so sometimes what happened, for identifying a problem, people use, you know, some brainstorming software. So usually those who works in the you know, artificial neural network, or you know, you see in those places, you know, what you can do is that you can draw some graphs, you can see some causal inference, you know, and that helps, you know. And even these days, like, you know, there are some you know, tools where you change different things and see what happens, right? That may give you some more idea, right? So software sometimes help. Okay, then delineate your problem. So delineate your problem is that for your problem, you really really need to say what are your assumptions. Okay, what are the things you are not addressing? You need to be very clear. Okay, I'm really addressing this, I'm not addressing that thing, and what are my assumptions, right? So so to do that, you know, for that for the deleting the problem, what you might want to do is that for your problem, are you going to use some theoretical framework or conceptual network? Okay, if there is any you know, prior hypothesis, you know, you think that okay, this this will work, you know, that your assumptions, right? You write it as a hypothesis, right? And for that particular one, what you do is that you try to identify the variables, and variables is which are related to that particular concept you're talking about. And when you find out variables you'll see later are 2 types, you know, dependent, independent variables, right? So dependent, independent variables, sometimes you have some intermediate variables too, right? From dependent to intermediate, something intermediate. So you see, all those things, you need to identify, and it will then it will really help. Then even in your even in your pressure problem, see what are the terms you have. Do you need to define any term, or are you going to use the existing definition, or you try to come up with something where you need some terms. So you really need to define those terms. Okay, you really need to state all the assumptions, and then write down the delimitations and limitations. What you are really addressing, what you are not addressing, right? So what is out of the box? So you should have the idea when you are trying to solve what you are solving, what you are not solving, what is the relationship. All those really help for your particular problem you are addressing. So basically, there are two types of framework, and all of us know. One is like theoretical framework. Theoretical framework means already there is pre-existing some concept. There is some principles, some relationships, causal effect relationship, or any other relationship just already there. That's a theoretical framework. But there is another one where you do not have really that kind of theory established, but you have some concepts, and you have some, among those concepts, there are some connections, right? So either you can use this one or the other one, depending upon what type of problem you are doing and how close you are, So for example, if it is a really something where you have to really start with some 3-4 concepts, and as time goes from those concepts, you need to try to find out the problems, the issues, come up with the solutions. So usually we have two type of framework. One is theoretical, and the other one is conceptual framework. Okay. So right now we know the problems, right? We don't know the problems, we know the sub-problems, and we are saying, okay, sub-problems are, we are trying to see, okay, these are like aims. So what you do is that there you try to write the hypothesis. Okay, you try to really state the hypothesis. That means, what are your reasonable guess that we are thinking, okay, for this particular one, this will happen, right? Those are your guess. Those are, you can consider like, okay, those are, your hypothesis. And before you to go into that, if you address that, okay, if you write it down, okay, those are kind of, a priori hypothesis. But as time goes, what happened, whatever hypothesis you are thinking about, you might do some counter example type of thing. That means you are trying to disprove something, So if you go that route, that route is, kind of, null hypothesis. Okay. So usually what we do is that null hypothesis is during the analysis, you try to come up with those. Okay. Come up with those. But usually what we do is that we write the aims and then try to come up with a set of hypotheses. And set of hypotheses is nothing but reasonable guess. And those guesses you try to really prove or disprove, right? So that's the way it works. So so the hypothesis is really really important, and particularly hypothesis I was just telling you is that when you have hypothesis, those are kind of reasonable guess, right? And that reasonable guess, when you write it down, you try to like prove or disprove, right? You prove or disprove. Sometimes we give counter example, and that way we try to kind of we try to have that rejected, right? Okay. So if you go that route, that's called kind of null hypothesis. But most of the time what we do is that we do a priori hypothesis, because we write the assumptions, and for those assumptions we try to see how we can move forward with those hypotheses, and that will establish whatever you are trying to solve, right? So each of the aim, you have some hypothesis, you prove or disprove. Second one, you prove, disprove. Together you will see that you are really solving a problem. So So whenever you have those hypotheses where you have some concepts, and among those concepts you have variables, right? Among those concepts you have variables, okay, and those variables C you can quantify or not. That's very important, right? Okay, if you try to have understand about the variables, try to quantify, and even these variables, if you can identify, that will help you for your research design, okay, for your research design. Because if you know the variables, then you think that, okay, I'm going to do some intervention where one group I'll not do anything, another group will do some intervention, right? So you can really compare, right? Or if you have like kind of, half you are doing and half you are not, right? Okay, so in that case, it will really help you to come up with a good or appropriate research design and even appropriate statistical analysis. So what I'm trying to say is that the concepts you are trying to talk about, address, in those concepts, find out what are the variables, find out what are the variables. So the variables, the best thing is that the variables are two types. One is independent variables, those does not have any relationship with any other things, straight away you are getting those variables value, those are independent. And some are dependent variables. Okay, dependent variables are partially influenced by independent variables. So actually from math, probably you are familiar with dependent and independent, right? Independent, it doesn't depend on anything, the word says, and dependent means right, which is really influenced by some other additional independent variables or not. So here I'm trying to give you an example. Let's assume, take the example of the consistency of ice cream depends on the temperature at which it is stored. So the ice cream, okay, the consistency of ice cream. So here you see is that's the dependent variable. The consistency is the is the dependent one. Independent one is that where you are really storing. So your ice cream, if you increase the temperature, what will happen? It will melt. So you see, it has direct consequences, right? Okay, so that's like dependent. And the independent on is, for example, you are storing in low temperature, then it becomes it becomes really solid. It becomes solid. So so in a domain, try to find out which one is dependent on another one, or what are the really independent one. One particular thing is changing, that's the independent one, right? So that's like really high level. We are talking about dependent and independent. And in your research, whatever you're trying to do, try to find out dependent, independent, because that will help. And later in our next class, we'll introduce something even intermediate. Okay, something intermediate between dependent and independent. Okay. And dependent and independent, that really helps in terms of analysis, how you do, even if you try to do modeling, if you try to do simulation, you need to know those value of the variables. Okay. So today, I was just trying to like introduce the concept of research, how do you select research, all those things, and we are moving into this one, dependent and independent variables. So in our next class, I'm going to continue from here, and with more examples, we'll see how we establish different relationship between dependent and independent, and we'll talk more about that. Okay. So we'll continue again the next class. and your presentation is not next week, even following week, so probably next week I'll give you more guideline how we are addressing the presentation. But if the presentation will be very, very short, because one class I want to finish everything. Okay, so that means people will not get more than 3-4 minutes. Okay, at most 5 minutes. Okay. Okay, so anybody have any question, concern?
I have one question. I couldn't find the slides for this lecture.
Okay, I think when you saw, okay, let me check. Thank you. Probably I did not open up, but I think I did right before the class. Let's see. So go to the lectures. Okay, lectures. Okay, yeah, you are right. Then you get some extra points, right? I thought I opened it up.
All right.
Okay.
All right,
Okay.
thank you.
So, now is lecture slide 1 and 2, chapter 1 and 2 are open. Okay, and anybody else have any other question? If not, I'll stop here. I'll also stop recording. I'll stop recording.